isomerism, structural isomerism, geometrical isomerism, optical isomerism. So, these are the few terms that keep us tingling throughout the year. So, to have the clarity about these terms, we are going to discuss the part 3 of the nomenclature of geometrical isomerism. Myself Dr. Sandeep Kumar Bansal welcomes you all in this part 3 lecture of the nomenclature of geometrical isomerism. In our previous 2 lectures, we have seen that what are the content that are to be discussed in this unit second, namely they are geometrical isomerism, conformational isomerism and stereoisomerism in bifinary compounds, stereospecific and stereoselective reactions. In our previous 2 lectures, we have seen that what conditions are required to exhibit geometrical isomerism, that was presence of restricted rotation around an olefinic bond and the presence of 2 different types of substituents around the olefinic bond. In next lecture, we have discussed about the orientation or arrangements of these substituents if they are present on the similar side of the double bond, then we have called it as a cis. If they are present on the opposite side of the double bond, we call them as a trans. Now, we have to go for the extension of this cis and trans isomerism, and this is syn and anti and E and Z system, and we will mainly focus on the examples that we are taking from alkenes, coordination complex and the cycloalkanes. Now, if we focus on this example, this particular example have all the 4 substituents different from each other: bromine, fluorine, chlorine and iodine. A, B, C and D. All the substituents are differ from each other. Now, can we assign cis trans system? Because in our previous lecture, we have discussed that to assign cis and trans, similar groups must be present on same side, and to assign trans, similar groups must be present on the opposite side, means they have to follow the X like structure, they have to follow the H like structure. But what to do in this case? Because all the 4 substituents are different. So, how we can assign them cis and trans system? So, my dear students, in these type of arrangements, we cannot apply cis and trans system. Rather, we have to apply more complete, more robust system to naming these alkene isomers, and this system is called EZ system. System is called EZ system, and this system is based on the same priority rule that we have discussed in the unit 1 to follow the RS system, Renaissance and Sinister system. So, using that same priority rules, we can assign the EZ system. So, EZ system, let us go some basic. According to this method, if groups are with higher priority, what we have to do? We have to assign the priorities. We have to assign the priorities to the substituents. We have to give them higher priorities, low priorities. If the groups with higher priorities are on opposite side, remember condition is again same, opposite side. So, if the groups with higher priority are present on the opposite side, we are representing it the letter E. E is a German word that stands for antigen. We can synonym it as enemy, means as enemy stay away from each other, opposite to each other. So, similar fashion the higher priority groups are present opposite to each other. So, we are calling that configuration as a E. if they are present on the same side of the double bond. We are representing them by Z, and Z stands for Zusammen, and meaning of this letter is word is together. If higher priority groups are present together on the same side, we are calling it as a Z. If they are present opposite to each other, we are calling it as a E, and both the represented with the in a bracket and separated from the hyphen like E Z. So, this how we are representing this E Z system of nomenclature. Now, we have to go more and deeper to see this. How now the steps, what steps are involved in the E Z system. So, first of all, determine the higher priority groups on each end of the double bond. Means, if this is the case A, B, C and D. So, first of all, designate carbon separately 1 and 2. First of all, what we have to do before determining the high priority? First, simply designate the carbons, otherwise we can commit the mistake. So, to avoid mistake, what we have to do? We have to designate the carbon 1 and 2, then determine the priority of each end of the double bond. Now, after assigning the priority, we have to look over the orientation of these groups. If they are present on the opposite side of the double bond, simply we will represent with the letter E. If they are present on the same side, we will represent with the letter Z. Descriptor, we will use descriptor E, we will use descriptor Z. So, simply there are 3 steps. First is the designation of the carbons, second is the priority determination, and third is the observation of the orientation of the higher priority groups. So, my dear students, we have to do 3 steps. First of all, designate the carbons, then determine the priority, and then observe the configuration whether they are present on the same side or they are present on the opposite side. If they are present on the same side, we will call them Z. If they are present on the opposite side, we will call them the E. So, what are the different priority rules? These priority rules are called Kahn-Ingold Prelog sequence rule. In short, they are called CIP rule, Kahn-Ingold Prelog system. Same system, similar system is being used in the nomenclature of RS system. So, what does rule 1 say? Rule 1 says that examine the atom directly attached to the compound. We have not supposed to look over the atoms that are very far, beta, gamma, delta. No, we have to look upon the alpha, that is the very near to the compound, first atom that is directly attached to the compound. Substituent with higher atomic number is given the higher priority. Substituent with higher atomic number given the higher priority, and the substituent with lower atomic number will given the lower priority. So, in this case hydrogen bears atomic number 1 in periodic table. So, that is why hydrogen get the least priority, lowest priority. So, hydrogen is with lowest priority, and the atomic number with atom or substituents with higher atomic number will get the higher priority. So, this is rule 1. Let us take example. In this case, what we are doing? First of all, my dear student, designate the carbons 1 and 2. Designate the carbon and let us see, observe the carbon number 1. Carbon number 1 bears 2 substituents, one is hydrogen, another is the iodine. So, which is having higher atomic number? Obviously, iodine. So, we will give higher priority to the iodine. Now, come to the carbon number 2. Carbon number 2 is bearing 2 substituents, bromine and chlorine. So, students, which is having higher atomic number? Obviously, bromine. So, having higher atomic number, bromine is given the higher priority. So, what I have did? I have observed the step 1. In step 1, I have designated the carbons as 1 and 2. Then I observed around the carbon number 1 and observe that 2 substituents are there, hydrogen and iodine, and iodine is obviously having higher atomic number than hydrogen, so given the higher priority. Now, observe the carbon number 2, it bears bromine and chlorine. Bromine is having higher atomic number as compared to chlorine. So, again it is giving higher priority. Now, in next step, just focus over the substituents with higher priority. So, substituents with high priority are bromine and chlorine. Now, look over their orientation. Bromine and iodine are present opposite to each other. So, means it will be designated as E-bromochloroiodoethene. But in this case, if we see iodine and bromine are present on the same side. So, we are calling it Z-bromochloroiodoethene. So, I think using this example, you must have an idea how to proceed with EZ system of nomenclature. If the higher priority groups are present on the same side, then we are calling it as Z. If they are present on the opposite side, we are calling it as a E. Rule 2. This rule talks about the isotopes. If various isotopes are present as a substituent, for example, in this case hydrogen and deuterium are present as a substituent. So, obviously, the isotope with higher atomic mass, because isotopes will be a same atomic number. So, here we cannot take the advantage of atomic number. So, if isotopes are present, then we have to go for the atomic mass. So, the isotopes bearing higher atomic mass will be given the priority. So, in this particular case, again designate carbon, carbon 1, carbon 2, here hydrogen and deuterium are present. So, we are giving the high priority to the deuterium, and this side hydrogen and methyl are present. So, methyl is will be given higher priority. So, methyl and deuterium are present opposite to each other. So, therefore, we are giving it the designation as E isomers, and in this case methyl and deuterium are present on the same side. So, we are calling it as a Z isomers. So, my dear students, if different substituents are present, we have to go for atomic number, but if isotopes are present, we have to go for the atomic mass. Rule 3 says that if there are two substituents with equal rank, proceed along the two substituents chain until there is a point of difference. Means, if substituents are similar and they are present in the form of a chain. So, how to assign the priority for such type of substituents? So, in that case we have to go for up to the point of difference. What does it mean? So, first of all determine which of the chain has the first connection to an atom with the highest priority. We have to identify an atom with highest priority. How to designate it with? Means it must have the highest atomic number. So, we have to identify the point of difference, and if the chains are similar, proceed down the chain until the point of difference. So, we have to proceed, one have to proceed till we find out the point of difference. So, it will be clear with some examples. Let us see it. See, this is the chain. In this case, what is happening? Carbon, consider this carbon and this carbon. These carbon bearing 3 different substituents, let me call it 1, 2 and 3. All the 3 substituents are hydrogen. In this case, there are 3 substituents 1, 2 and 3. So, in this case 2 substituents are hydrogen, third one is the carbon. So, this is similar, let us cross it. This is similar, again cross it. Now, third is different. This is hydrogen, this is carbon. So, this is the point of difference, and which bear the higher atomic number? Obviously, the carbon. So, therefore, this will get the high priority. So, this is the with the substituent with the high priority, this is the substituent with the lower priority. So, in this type of cases, we have to go like this. Let us have one more example. If we look upon this carbon, these two carbons are substituted with hydrogen. So, this is equal, so cross it. It is methyl, again equal, cross it. Look upon the third substituent, this is hydrogen, this is methyl. So, obviously, methyl is having the higher priority as compared to the hydrogen. So, this will have the higher priority, this will have the low priority. So, this is we have to find out the first point of difference and their relative atomic number. In case they are isotope, then we have to look for the atomic weight. Let us go for this. So, we have to cancel out the similar again, similar cancel it, similar cancel it. So, we are looking around this carbon. Now, this third substituent is looking different. So, what is the difference? Difference is one is methyl and another is the bromine. So, obviously, bromine is having higher atomic number as compared to methyl. So, it will give the higher priority. I hope students, with these examples you must have the clarity how to utilize this CIP rule in assigning EZ configuration. So, on the basis of this rule, we can see this propyl, ethyl, methyl and hydrogen. So, propyl is having highest atomic priority, this ethyl followed by methyl followed by hydrogen. So, longer hydrocarbon chains are getting high priority, longer hydrocarbon chains are getting priority. Now, what happens? See, this is an example here, designate these carbons 1 and 2. Observe this, methyl and hydrogen. So, this is high priority group, here this is high priority group and both are present on the same side. So, that is why we are calling Z, but in this case the higher priority groups are present on the opposite side. So, we are calling it as a E. So, similarly, here you can see that among these two substituents, this is having high priority, among these two substituents it is having high priority. So, these two high priority groups are present on opposite to each other, that is why we are calling it as a E. So, we have to look upon whether these substituents with high priority are present on the opposite side or whether they are present on the same side. Rule 4, treat double and triple bond as an indivisible entity, they are treat them as a separate bond and designate and consider it as a phantom atom, consider it as a phantom atom. So, let us have a look, let us have an example over this. So, if we see this here we can see this double bond, this CH double bond CH2. What we are doing? We are considering this as a double bond as a substituted with 2 equivalent to different carbon. Here it is acetylene, we are considering it as equivalent to 3 triple bonds, 3 single bonds each is ending with the 3 carbons. So, 3 phantom atoms. So, here this acetylene substituent is ending with the 3 different carbons, here it is ending with the 2 different carbons. So, point of difference, carbon cancel carbon, this carbon cancel carbon, among this carbon is having higher priority over the hydrogen. So, therefore, over this is high priority, this is high priority, and both high priority groups are present on the same side. That is why we are calling it as a, we are calling, sorry, here you can see this methyl group is higher priority this side, and this side is acetylene is having both higher priority, and both the groups are present on the opposite to each other. That is why we are calling it as a E. In this case, higher priority groups are present on the same side, that is why we are calling it as a E. Similarly, this is one more example. In this case, this is group with higher priority, this is the group with higher priority, and both are present on the opposite side. So, we are calling it a E. In this case, both the higher priority groups are present on the same side. So, how we are this, we are C double bond O, we are considering it 2 single oxygen atoms and here 2 single carbon atoms. So, in this case, oxygen is having higher priority as compared to the carbon. So, by comparing or by considering these multiple bonds as a single atoms, we can assign the priority. Now, if there is a chain polyenes, how to go for the number of geometrical isomers? There are 2 types of conditions. If the ending groups are different, if the ending groups are different, say here this is phenyl, this is chloro. If ending groups are different and number of geometrical isomers will be 2 to the power n, and here in this case consider count the number of double bonds 1, 2, 3, 4. So, such type of compounds will exhibit 2 to the power 4, that is there will be 16 geometric isomers. So, in a polyene compound that is having 2 different ends, and number of double bonds will definitely give an idea ki how many geometrical isomers will be there. But what happens if both the groups are same? In this case, we have to go for even. If number of double bonds are even, number of double bonds are odd. So, in that case formula will be different, 2 to the power n minus 1, 2 to the power n upon 2 minus 1. Here double bonds are 1, 2 and 3 and 4. So, we are implementing formula, we are getting the 10 geometrical isomers. Here n is 3, 1, 2 and 3. So, we are implementing formula, we are getting the number of geometrical isomers is equal to 6. Similarly, syn and anti nomenclature is identical to Z, Jusamen and E4. So, this type of nomenclature is present in carbon nitrogen double bond, and easily here you can see that if we are giving the lowest priority to the lone pair, if lone pair it is say it is syn, it is anti. So, syn isomer would be called equivalent to the Z isomer, and the higher priority groups are attached in the same side, we are calling it as a syn, otherwise we are calling it as a anti. So, syn is equivalent to Z and anti is equivalent to the E. This type of isomerism is also available in aldoxymes, and azo compounds also exhibit syn and anti isomerism. So, dear students, you can have practice with these some examples. Let us see. So, you can assign EZ nomenclature on the basis of the rules we have discussed so far. So, here are the answers, you can see these are the answers to the different nomenclature system, and here are 2 more examples. Try to assign nomenclature on the basis of rule, and this is the answer. Similarly, there are 4 more questions, you can use them for practice, whether they are having the E or Z configuration. So, these are the answer to these questions. So, thank you very much. I hope you must have understand the application of E Z system for the geometrical isometry. Thank you very much.